Good morning, the beautiful people of DevOps Pro Europe. So, sounds not bad. So, actually, the beautiful people is the greeting which Freddie Mercury often used to greet his viewers, and I like it. And since it's the first talk in this hall, speaking about Freddie Mercury and Queen and other rock bands, when they played together on different festivals, some of them actually liked playing the first ones during the day, or the first one in the conference or in the festival in general. And there are two reasons. The first reason is simple. If you play the first one, then you are done very quick. You don't have any responsibilities anymore, and you can enjoy the rest of the party. And the second reason is, if you play the first one, you kind of set up a mood for the audience for the entire day. And I'm sorry for that, but that's what I'm going to do for you guys. And if this doesn't work, let me know in the end. So today, as you can see, we're going to talk about smart data-driven alerts and how they make our life easier. So the term smart data alerts, the abbreviation, it's about alerting, meaning sending some notifications, warnings, critical information, and other kinds of notifications to different channels. It's data-driven because it's connected to your databases or other sources of data. And it makes queries, and then based on these queries, it takes decisions what to do. And it's smart because you can configure them, and you can actually configure two things. The first thing, you can configure the queries, which then run against the database, against the source. And then you can configure the notification itself. You can decide what to do with the results of these queries. And usually the results of such queries are integers. And then you can write your expressions and decide what to do with that. And this abbreviation, Smart Data-Driven Alerts, actually didn't exist. I just made it up because sometimes it works if you want to convince some people to do something. It's a good way to use abbreviations because it makes it's serious kind of immediately. Like SDdA, Smart Data-Driven Alerts, that's cool. That's probably a good concept created by some big guys. But it's not. It didn't exist, and we will see it today. And so half of my presentation will be about a theoretical part, and half of it will be a demo where we will set up containers right here on stage, and we'll see how it works. So this is me, as you heard from the video. I'm a CTO and a co-founder at Billy, and Billy is a financial platform. It's a fintech startup. So we started 2 years ago, and what we do, we are basically financing the working capital of small and medium-sized businesses. So what it means is, imagine there are two businesses. The first one, two small ones. The first one is a small restaurant, and the second one, let's say it's a company which makes renovations. And this company made a renovation for this restaurant, and the restaurant has to pay. So the company which made the renovation, they issue an invoice, and the restaurant has to pay, but legally they have some time to pay for it. They have from 2 weeks to even 3 months sometimes. And this is, of course, not good for the company which made the renovation because they need this money as soon as possible. They need to pay salaries, they need to pay for materials, they need to pay to their suppliers. And this is the moment where we come on stage. So all of these expenses, it's called working capital, and we finance it by different ways. We have a platform, we have some open APIs which we integrate with shops. And of course, for that, we really need stable systems, and we need stable monitoring because it's money in the end. So coming to the point of monitoring of data, when I was thinking, that I would need to present in front of you in the cinema, it was a bit unusual for me, unusual feeling, because I've been once in such conference in the cinema, but I was there on your side, and in the audience it's quite normal, quite usual. There is nothing super special about this. You just sit and watch like you are watching a movie in a cinema. But here, being on stage while people are watching the movie, this is a bit weird feelings, I would say. And then I came to the idea that actually, I don't know if it exists here in Vilnius, but in Berlin, we have such people who are on stage right in front of the movie. So it's like a network of cinemas. It's not everywhere, it's just in one network of cinemas. And what they do when the commercials are over, when the trailers are over, right before showing the movie itself, they place the advertisement of an ice cream. So on a screen like this. So there is an ice cream. They have prices. I don't have them because it's a conference. It's already, you've paid already for that. So the ice cream is included. So what they do, they place this on the screen, and then the guy or girl with a box of ice cream comes to the stage like this, like I'm nowadays. And then they sell it to anyone who wants some ice cream. And to actually do this, let's make an experiment, a small experiment. Is it okay for you guys? Cool. So there is an ice cream. There are no prices. Let's imagine I have this box here. Does anyone want any ice cream? Which one do you want? Which one? Yeah, that's for you. Take it. Anyone else? There is this nice chili curry DevOps Pro Euro branded one. I don't know if it exists, but I just made it up. You want this? Yeah, that's for you, for you. Don't eat it now. Don't eat it now. I'll tell you when you can try this. Victor, which one do you want? Vanilla? Yeah, that's vanilla for you. Okay, so let's imagine everyone has an ice cream. Now you can try it. Now you can lick it and let me know what's the flavor. There is no flavor because there is no ice cream, right? So that's the wrong expectations, right? And that's how the monitoring of data works. You set up your expectations, you let me know what kind of flavor you want, but then you got nothing. And your mouth knows it, and it tells your brain that there is a wrong flavor, and it means that the expectations which you had in the beginning, they don't match the reality which you got. So that's basically the monitoring of data. The flavor of ice cream is a data, and the reality is what we get. And it's interesting that in most of the cases, companies simply forget about this simple concept. This works in many cases in life. We've just seen it. But we usually monitor many things. We monitor the performance of our instances. We monitor how our databases work. We monitor CPU, memory, but we forget about monitoring of data. We forget to monitor whether our data are consistent, full, and fully useful for our applications. So this is how the standard data flow looks like in, I would say, 90% of cases, in 90% of products. There is always a source of data, which can be your web application, your API, your microservice, or different other source of data. So what they do, they usually create some data, they produce some data in a certain format, and then they place it into the storage. So it gets stored in the storage. And then there are consumers of data, the services, the APIs, and maybe other products which use this data. And it could be even like the source of data and the consumer could be in the same service. It works as a source of data when it inserts the data into the database, and it works as a consumer when it retrieves it and then does something with that. So in this flow, in this standard flow, what could possibly go wrong? What could make the data incorrect or inconsistent? The first thing and it's the main one. It's of course bugs. Unfortunately, as we all know, there is no bug-free application in this world. All the applications have bugs. Very often it affects data, and then the data go to the database in a wrong format. The second one is the out-of-sync version of the code. This can happen when, let's say you have two services. The one service uses the database, and then the second one uses this part of this database for different purposes. It's against of all the best practices, that's for sure, but it happens sometimes. And it could happen that the version of the code in the first service is not, let's say, similar to the version of the code as it should be on the second service. This means that if the one service inserts some data in a good format, then another one updates the same data and makes it incorrect for the first service if the first service will use it again. So the third problem is insufficient validation rules. The good example here could go to the API. Like if you have a parameter in your RESTful API, and this parameter is a mandatory parameter. So far so good. You have a good validation rule for it. It should be mandatory. It should be present in a request. But that's it. So it doesn't tell anything else. It doesn't distinguish between integers and strings, for example. And then you can have a mess in your database between integers and strings in the same field. This one is the most critical one, the manual intrusion into the database. That's another really bad practice, but unfortunately it happens, especially in startups when the business is really growing fast. And the good situation which describes it is, let's imagine you have a customer support, and then one of your customers calls it and says, look, I have some wrong data in my account, and I cannot change it by myself because there is no such option in the account. Could you please do it for me? And of course we will do it because this is our customers, they bring us money. But unfortunately, sometimes it could happen that it's even not possible in our back office to fix this data, to change this data. And what we usually do in this case, we of course go to the developers or DevOps and ask them to change it right on production, which is of course bad, but it happens. And more we do this, then more potential issues we will create in our database. It may not even explode right now, but this could happen in the future, and this will be really painful. So that's the place where the monitoring of data comes on stage. So you see it's down there below the storage, and it works as a listener. So what it usually does, it does the queries against the storage with some period, and then it checks whether the data are expected or not. So usually it gets connected to the storage directly, but it's not one service sometimes, and we'll see it later in the demo that we would need more than one service to set it up. So why is it important to monitor data? What kind of benefits we get out of it? The first one is consistent inserts and updates. It's important because if we insert some data and then the same service reads it and then it updates it, if we have the monitoring of data and nothing happens, nothing shouts loud that, yeah, here we have a problem, then this means that inserts and updates work consistently. We will have the reliable select. So if we retrieve the data from database, and no matter who is a consumer of this data, if the monitoring works and it's stable and there are no problems, we can already assume that the selects of our data will be reliable and will work as expected. Sharing of data between services. That's exactly the point which I mentioned before when you have two services using the same database. If you share some data structures or some values from the database between those two services, we can be sure that this is consistent. Predictable reports. That's sorry. Yeah, predictable reports. That's also really a really important topic, especially for the BI, because if the company works with the certain consumers, then of course the company has KPIs, and these KPIs, the monitoring of them and the results, different graphs, they're coming from the BI reports, and it's quite common situation when the developers or the DevOps made some changes in the database and they forgot to notify BIs. And then the BI people, they come and scream, hey, our reports are broken because the data structure was changed or the values were changed in the database. So if we also set up a monitoring for it, then this should be fine. And this is the most important topic, the real-time awareness. What it simply means in a couple of words, if you are aware real time that you have a problem, you have a weapon to decide what to do with that. The good example for it is again an example with your customer who was calling to your customer support. If the monitoring of data is set correctly and it notifies you that there is a problem, it's in 95% of cases will be before your customers will see this problem. Could be because they are not online or simply because they are online but doing something else. And then you have a right to decide what to do with it. You can escalate the problem, you can postpone it, you can say, okay, it's fine, it doesn't look so bad now and it doesn't break anything, we can live with this, or you can go and fix it immediately. So it's up to you. The real-time awareness is here. So this is the principal setup of the monitoring system which we will do here. We have a data source, that's a simple database. We have a listener, which, as I mentioned before, which will connect to this database, and this will listen to the data changes in the database. Then this will generate some metrics in the integer format, and then this will send this metrics to the decision maker. And the decision maker is actually a tool which is responsible for taking a decision what to do with this metric. It can skip it, it can wait, or it can fail an alert, and this will also see. And then the alert receiver is a channel where these alerts go. So this is a channel where you as DevOps can see them. And this is the detailed setup, how it will look like. So we'll have our database. And by the way, if you set it up on production, I don't recommend using your production database because some of the MySQL queries could be quite heavy and your database might simply not be ready for these databases because of these queries, sorry, because it's a different purpose of the database. It's not optimized to be working with such queries. It's optimized to be working with your applications. So it's better to use either MySQL Slave or Data Warehouse if you have a real-time synchronization between production database and Data Warehouse. So the database is a source of data. Then we'll use a package which is called SQL Agent. It's an open source package which is on GitHub. And what it does, it provides an HTTP interface to run queries against the database. That may sound a bit strange because what's the point of having this? But we need this because we need this for the next service, for the Prometheus SQL. It's the service which is written for this by the same author. It's also open source. It's on GitHub and they work together. So what it does, it sends the queries to the SQL agent, to the HTTP endpoint on the SQL agent. And then the SQL agent runs these queries against the database, gets the result, and sends it back to the Prometheus SQL. And the Prometheus SQL generates metrics in a format which are compatible with Prometheus metrics. And then we send this to Prometheus, and the Prometheus is a quite common tool to be used by DevOps in the DevOps world. Does anyone use it here? Yeah, it's quite popular. And then the Prometheus there is a component which is called Alert Manager. We'll also see how it works with such metrics. And this Alert Manager generates the alerts. And what we will also do, we will send these alerts to Grafana, which I'm sure lots of people also use here. And in Grafana, we'll see the nice graphs about the historical data of the alerts. And there is also this line which is dashed, because we are not going to do this today, because for that we need some public channels to send this data, to send this alert. But in the end of the presentation, I will share a link that will be on the slide where you can read about setup, how to actually send these alerts from Prometheus to some public channels like Slack or Telegram or Gmail. There is nothing special, and probably you already even have it. So that's what we are going to do here. And let's start the demo then. So we would need this one. Here I have some code. And here I have my Telegram. Oh, sorry, my terminal. So I have my terminal where I will run the commands. So the first thing, I've already set up a database. We'll see it's a container here. Is it big enough, or should I do it bigger? No? Okay, fine. So we see there is a container with my SQL 8. And inside of this, I already created a database before. And this database has just one table. So there is a table which is called secret keys. So let's imagine that your application uses some secret keys for some purposes. This could be a secret key which you need to call other services or applications. That's quite common if you call third-party services. It's some sort of a token or the API key. Or it could be also a secret key which you use internally to encrypt some data. And of course, for such purposes, these secret keys, they should expire. They should have their TTL. And let's imagine that in our case, it's 90 days. So inside of this table, I already have some values. So if we look at the structure of my table, it's the following. I have an ID, I have a value of a key, and I have a date when it was created. And I already inserted 3 keys. Sorry. Okay. This we don't need. So there are 3 keys, and let's assume the latest one is always valid. So the key 3 is the currently valid key, and that's the structure which we will have. Now, if you, as you could already see on the left side of the monitor, I have here some commands. We'll run it one by one, not as a bash script, because I would need to explain step by step what we actually do. So the first container, the second container actually, apart from a SQL 8 which we're going to run, is the container with the SQL agent. So we go here and run it, and we see it's up and running. So we just run a Docker container with this tool, and we link it to the MySQL 8 container because we would need to know the host of MySQL, and we will do the queries. So the second container which we are going to run, 15 minutes, we've just started our game. Okay. So the second container with Prometheus SQL, for this we would need to have 2 configuration files. The first file is the file with the queries itself. So here we use the data source alerts, which I will show you in a minute. It's in a second configuration file. And against this, we will run this query, which we will calculate the difference between the moment when the key was created and now. And this will convert it into days. And this will be done just for the latest key in the database. And then there is one really important parameter, which is called interval, 10 seconds. This is the frequency which we will use to run these queries. So this query will be run by SQL agent and against the data source once per 10 seconds. And the second configuration file is this one. It's the configuration file of Prometheus SQL itself, and here we define the configuration parameters to connect to our database. So nothing more, nothing special. Okay, let's run this container. As you can see, it's linked to the SQL agent container as well. Done. The container is here, and now we can see some results already. We will see some metrics. So this is the page which it generates, and you see it's a Prometheus format, Prometheus compatible format. There are some default metrics which are coming from Prometheus SQL, but what's interesting for us is the last one. It's the query result secret age metric, and it says that the age of the latest secret key is 60 days. So far, so good. So now we need to run the Prometheus itself, and in the Prometheus we have the configuration file of Prometheus, which will use the Prometheus SQL metrics page as a target. So this will gather these metrics from this page, and in the Prometheus itself we define in the alert manager the rules of how we react to these metrics. This is exactly our decision maker. So here we'll have two alerts. The first one will notify us if the key is going to expire soon. So this will shut it out loud when the age of the secret key is between 85 days and 90 days. And here we also have one important parameter for 1 minute, which means that it won't send an alert if it sees the result of this expression first time. It should stay like this for 1 minute, meaning the frequency which we had before, it's 10 seconds. It means that we need to see this alert at least 6 times. And then there is another alert, which is already, it's important, and this will fire when it's already too late. So the secret key is already expired. It's more than 90 days old. So these are the two alerts, and let's run the container with Prometheus itself. Good, and now let's get back and let's go to the page with Prometheus. So this is this page, this is Prometheus, and these are the two alerts which we've just configured. And we see both of them are green because we know that the age of the secret key is 60 days. And this is what we can also see here on the main page of Prometheus. If we execute the query, we can see the value 60 here. So before we go and do some experiments with the data, we will also configure Grafana in order to see some historical data. So we'll just run a container with Grafana, and then we will configure all the alerts right on the web interface of Grafana. So this is Grafana. The default login and password are admin. We just use them, then it asks us to create some random new ones. We'll do that. And now we'll configure the dashboard where we will display the results of our metrics. So first thing we will do, we will add a data source. This is Prometheus, and the URL is standard. It's the URL where we have it up and running. And what we just need to do, we need to change the access from server to browser. Save and test. It works. So now the next step which we will do is we will configure a new dashboard where we will display the results of our query. So here we can already see this metric, so we configure it here. But apart from that, we will also configure two thresholds. The first threshold will be a line which is above 85 days. So this is a threshold when we need to change our our key when we need to refresh our key, but it's still working. So the application is still working. That's why it's not going to be critical. It's a warning. And the second one is when it's above 90. This will be a critical information when it's already more than 90 days. So everything is done. We save a dashboard, and we can already see the current metric here. 60 days. It's already up and running. Now let's get back. And now what we can do, we can go back to the database and do some changes. The first thing we will do, we will make our key, let's say 88 days old. So we change it here. And now we can see how it gets changed in all the services which we currently use. So here on the metrics page of Prometheus SQL, it's already changed. It's already 80. Let me make it bigger. It's already 88. Here it is. Prometheus itself reacts also fast. So we will see it here as well. That's 88 here on the Prometheus side. And the same thing should happen here in Grafana. Yes. You see it's already above the threshold, the first threshold which we set up. It's here. That's the current value, 88. Now, if we go into the page with the alerts, we can see that the first alert became yellow. And if you click on the detailed page of it, we see it's pending. So that's exactly what I meant before. The Prometheus Alert Manager sees the first time that something is wrong with this secret key, but it doesn't fire an alert because it needs to stay like this for 1 minute, just to be sure that it's really a problem. So we are not going to wait it because we might run out of the time. We'll go to the database and make it even worse. We'll make it, let's say, 95 days old. So yes, it was changed. We can already see it here on the page with metrics. It's 95 days old. And let's get back to the Prometheus because it's probably, yes, it's already reacted to the previous alert. As we can see, it became red. It's firing. And it means that at this point in time, you will already see it in your channel, which you use for notifications. It's either Slack or Telegram or any other. And we'll see it later. I also have a slide where I will show you how it looks like in Slack. And if we go back to the dashboard here, we see that it got changed as well. Yes, so it's now here, 95 days. So what we need to do, we need to get back and refresh the key, but we won't do this. We'll just make it 60 days old. So now it's again valid and it's supposed to work. So here it is, 60 days. If you go to Prometheus itself and we query the result, it's still the previous one. It's not yet up to date. Now it is. So it's 60 days. And here on Grafana we'll also see this change. Yeah, it's got back to normal. So this is approximately how it works on production. And as you can see, it's a really, really good practical tool. It's very easy to set it up. You just need a couple of configuration files and then everything is up and running. And now let's have a look how it will look like if you use, let's say, Slack for your communication channel and for the monitoring. So this is a screenshot from our Slack. You see there are this is the alert, exactly the alert which we've just configured. If it starts firing this alert, it sends the first notification, which is red, and it says, please react to it. When it's resolved, what's good about this, it sends the second notification to Slack and it tells that everything is fixed, which also keeps the information up to date. So that's pretty much it. What I just want to say as a conclusion, the first thing which we've just seen, that smart data alerts are a good way to monitor your data. It's definitely stable, it's reliable, and it helps you to control what you have in your database. But there is one important topic which I want to worry you about it. The smart data alerts is your last line of defense. What it means is you have your development project, you have your development process, you have your deployment process. If you use Scrum and you develop a new feature, or your developers, it gets groomed, it goes to the sprint, it gets estimated, then it goes to the programming, it gets developed, covered by tests, ideally. Then it goes to the QA tests it, they also may cover it by test automation. Then it gets accepted, and then it goes on some pre-production or test instances, then pre-production, and then production itself. So it's a really long way for any change is happening in your product. And only then it gets released on production, and then the smart alert might tell you that something is wrong. And it's good to use this as an indicator, but probably if you have a lot of problems with the data, it's better to look not into them when they are already on production, but before, and change your process or change the way how you work with some things. That's pretty much it, except one thing. I also promised you a link to the article where you can check it, and here it is. So there is a QR code and a link to our engineering blog on Medium, where we write articles like that as well. And this article is also there. You can check more examples and configure the smart alerts by yourself. Thank you.